Okay, what we're going to be doing today is creating hydrogen for a PEM fuel cell. This hydrogen is going to come in the form of an aluminum-water reaction. Aluminum and water react to make hydrogen and aluminum oxide. So what we have here is a regular piece of household aluminum foil. Tear this thing into some small strips. Place it in this jug of water. Have a water level about right here. As you can see, I've already put a fair amount of aluminum foil in there already. And you can also see that there's no reaction going on. That's because aluminum has an oxide coating on it. So in order for aluminum to react with water, this oxide coating has to be stripped away. To do that, in our project, we use gallium. Now, for the sake of this experiment, I couldn't get my hands on any gallium, so to substitute it, I'm going to use some crystallized sodium hydroxide. Alright. So what gallium or sodium hydroxide do is merely strips the aluminum of the oxide, which enables it to react in water. So by doing this, when you place it in the water, what the aluminum does is it robs the water of the oxygen, which liberates the hydrogen molecules and turns it into the form of hydrogen gas. Now that hydrogen gas is going to fill up in this bottle. It's going to come via this hose. Have this bottle here filled about this high with water. This inlet hose here comes well beneath the surface of the water. This exit hose right here comes just below the depth of the cap here. This hose is smaller, acting as a regulator. What's going to happen is pressure is going to build up inside this bottle, and it's going to force the hydrogen gas through here into this makeshift burner. So what we have to do is make sure we don't add too much reactant. This reaction is going to be highly exothermic, which means it's going to put off a lot of heat. To give you an idea how much heat this thing's going to put off, roughly about 31 kilojoules of heat per gram of aluminum foil, which is a lot of heat. So hopefully I'll have this mixture correct, and like I said, we'll just be careful. Okay. Okay, so starting already, which there's a little concern right there. I hope it doesn't get too reactive. Now what I have to do is I have to allow enough time to displace the oxygen out of this container. What's going on? Okay, well, it's better to be a slow reaction than a fast reaction, I promise you that. Okay, it's starting to go now. Like I said, this oxygen is going to be displaced by this hydrogen gas. Once it gets enough displacement out here, it should... Whoa! Oh, okay, let's try it again. Whoa. There we go. Alright, that's exciting. So I think I got a little too much reaction, so I'm going to step away from this thing right now. I'm going to let it go and let you see what it does, how long this thing's going to burn. Alright, now this hydrogen, the water is an excellent place to store this hydrogen, because you actually get about 1,300 liters of hydrogen from 1 liter of oxygen. I mean 1 liter of water, I'm sorry. If you were to hook this up, rather than hook it to a burner, if you were to hook this system up to a small fuel cell, maybe a 5x5 portable fuel cell, it'd probably produce 17 to 18 volts at 5 psi pressure. 17 to 18 volts would be enough to power up a laptop. If you could sustain this amount of hydrogen gas in liters per minute, to give you an idea of how much it could fuel up, is that a regular 4-cylinder car would use 1 to 2 liters per minute of a hydrogen fuel car. So, like I said, if you could sustain this, it'd be very beneficial. Okay, now, like I said, it's a very dangerous and volatile gas. If you're going to try an experiment like this at home, please take care. I'm going to shut this thing down for right now, and thank you for your time.